and can be 1,000,000 degrees Celsius. That's about 1.8 million degrees Fahrenheit. Scientists aren't sure yet why it's so much hotter than the surface. It may be due to magnetic activity, but this is one of the big mysteries of the Sun. The next layer is the chromosphere. This thin layer goes from corona temperature to surface temperature very quickly. The visible surface of the Sun is called the photosphere. This is where all of the visible light that reaches Earth is emitted. It's also the coolest part of the Sun at 5,500 degrees Celsius, or 10,000 degrees Fahrenheit. Just below the photosphere is the convection zone. Here, hot material boils up toward the surface. The plasma at the bottom of the convection zone is around 2 million degrees Celsius, or 3.6 million degrees Fahrenheit. Below the convection zone is the radiative zone. Energy bounces around so much in this layer that it takes 170,000 years for a single photon to escape, even though it's moving at the speed of light. Finally, the core. The heat and pressure in the Sun's core are so great that atoms of hydrogen are smashed together to form helium. This process is called nuclear fusion, and it produces the immense amount of energy that will fuel our star over the course of its 10 billion year lifespan. Energy leaves the core as photons. They bounce around the radiative zone for 170,000 years, boil upward through the convection zone, and are finally emitted from the photosphere. From there, the photons travel nearly 150 million kilometers, or 93 million miles, to the Earth in only 8 minutes. The Sun emits light across the entire electromagnetic spectrum. But high-energy wavelengths like ultraviolet, X-rays, and gamma rays are incredibly dangerous to life on Earth. How can life survive all of that dangerous electromagnetic radiation? The answer is Earth's atmosphere. The envelope of gas that surrounds our planet blocks nearly all of the dangerous wavelengths of light. The visible portion of the electromagnetic spectrum, the light we can see, passes right through. So do some radio waves, microwaves, and infrared. They help keep us warm. In addition to heat, light, and energy, the Sun also bombards the Earth with high-energy particles. These particles come from the corona. This is the solar wind, and it streams from the Sun constantly in all directions at speeds of 400 kilometers per second. That's about 1,000,000 miles per hour. If the particles